Hello and welcome everyone. In the last lecture, we have seen question number 1, 2 and 3 from exercise 5.1. Now, in today's lecture, we are going to start exercise 5.1 question number 4. So, fourth question is, prove that the function f of x is equals to x raised to the power n is continuous at x is equals to n, where n is a positive integer. So, we have given the function f of x is equals to x raised to the power n, and we have to show that this function is continuous function at x is equals to n, where n is positive integer. So, one thing we can say surely that function is well defined at x is equals to n, where n is a positive integer. So, we can say that f of n is equals to n raised to the power n. Now, let us find the limit of this function. So, limit x tends to n f of x is equals to limit x tends to n x raised to the power n. Now, it is equals to n raised to the power n. So, as you can see, the function satisfies its definition. That is why we can say that limit x tends to n f of x is equals to f of n. Here from this and this we can write limit x tends to n f of x is equals to f of n. So, the function f is continuous. So, this is our fourth question. Now, let us move to the next question, which is fifth one. So, our fifth question is the function f is defined by f of x is equals to x if x is less than or equals to 1 and 5 if x is greater than 1, is continuous at x is equals to 0 or at x is equals to 1 or at x is equals to 2. So, here the question is that we have to find whether the function is continuous at this 3 point or not, right. So, let us start with x is equals to 0. So, for x is equals to 0, so for x is equals to 0, f of 0 is 0. Why f of 0 is 0? Because we know that 0 is less than 1. So, for all the points which are less than 1, the function f of x is equals to x. So, for f of 0 we get 0. Now, let us find the limit of this function. So, limit x tends to 0 f of x is equals to limit x tends to 0. Now, what is f of x here? It is x. So, let me write x is equals to limit of this function is 0. So now we can say that limit x tends to 0 f of x is equals to f of 0. From this we can say that so function f is continuous at x is equals to 0. Now similarly we will prove this for x is equals to 1. But for x is equals to 1 we need to keep this in mind that left limit and right limit should coincide. Why we have to check that? Because function is defined differently for both the sides. From left side of 1, that means all the points which are less than 1, function f of x is equals to x, and for all the points which are greater than 1, function f of x is equals to 5. So it is necessary that limit of a function from the left side and limit of the function from the right side should coincide. So let us start. Let us check that for x is equals to 1 we have f of 1. Now what will be f of 1? So it is really simple. Here you can see that x is less than equals to 1, f of x is equals to x. So here we have equals to 1, so f of x is equals to x, that means f of 1 is equals to 1. Now let us find the limit of this function. So first of all let us find left limit of the function. So limit x tends to 1 minus, so here 1 minus, that means all the points which are less than 1. F of x is equals to limit x tends to 1 minus x, because function is defined like that for all the points which are less than 1. So which is equals to 1. So our left limit is 1. Now let us find our right limit. So limit x tends to 1 plus f of x is equals to limit x tends to 1 plus 5. Now I have written here 5 because all the points greater than 1, for that f of x is equals to 5. So that's why I have written f of x is equals to 5. Now which is equals to 5. So as you can see here, our left limit and our right limit does not coincide with each other. 1 minus f of x is not equals to limit x tends to 1 plus f of x. So these two are not equals, that's why function f is not continuous at x is equals to 1. So this is, we can, from this we can also say that the function f, for the function f of x, x is equals to 1 is the point of discontinuity. Now let us check for x is equals to 2. So for x is equals to 2, first of all, what will be our f of 2? It is really simple. It will be 5 because 2 is greater than 1. That's why f of 2 is 5. Now let us find the limit of this function. So limit x tends to 2 f of x is equals to limit x tends to 2 5, which is equals to 5. So here we can say that limit x tends to 2 f of x is equals to f of 2. That's why f is continuous at x is equals to 2. So from this what we get? We got that function is continuous at x is equals to 0 and x is equals to 2, but it is not continuous at x is equals to 1. So for this function the point of discontinuity is 1. So rest of the question we will solve in the next class. So till then, goodbye, take care.